Our method of inference that we are learning today is a one sample t-test for mu. Let's get started. The USA Today reported that the state with the longest mean lifespan is Hawaii, where the population mean lifespan is 77 years. A random sample of 20 obituary notices in the Honolulu Advertiser gave information about the lifespan and years of Honolulu residents. Do we have evidence that the mean lifespan in Honolulu is less than Hawaii's average? Step 1, we want to state our null, our alternative, our parameter, our population parameter, and our alpha. Okay, in that state, I always want to start with that population parameter. Why? That's telling the story. What is this story about? We're dealing with mu today, okay? And when we do that symbol, that's that kind of weird M right there. So our mu is equal to the true mean lifespan of Honolulu. Okay. Our HO, we always assume the truth about the population. So we're going to make an assumption that right now Honolulu mirrors that of Hawaii. 77 is describing all of Hawaii. Honolulu is part of Hawaii. So we're making an assumption there that mu is equal to 77. We are wondering though if we have evidence that it might be less than 77. Our alpha, our significance level, is not stated, so we assume that is 0.05 unless otherwise stated. We should feel comfortable with our state where we need our null, HO, our HA, our alternative, our population parameter. Mu is equal to the true mean. And then again, you would just fill in the blank here. What is the context? Remember our null hypothesis in AP stats, we always have equals right here. And then our alternative will be a less than, a greater than, or a not equal to, dependent on the key word. In this case, it does say less than. That's how I knew it was less than. And then our alpha, our significance level, that is 0.05, unless they tell you something different. The next thing we need is our plan. We know that we need a random sample for our condition, okay? So R equals a random sample. In the problem, it does state a random sample of 20 obituary notices, okay? So random sample N equals 20 obituaries notices, okay? That's our 10% rule. That's what allows us to use that standard deviation. So I'm going to take 10 times 20 is less than all obituary notices. Now our normal condition, this is where people can get mixed up. Remember, when we're dealing with a proportion, that is that NP is greater than or equal to 10, and then N times 1 minus P is greater than or equal to 10. In this case, though, because we're dealing with means, we want N to be greater than or equal to 30. And I can actually go to the board here, so I'm going to do that now. And if N is not greater than or equal to 30, we can proceed. So if N is greater than or equal to 30, we're good. Or we want it to state a normal population. If it doesn't say that N is greater than or equal to 30, and it also doesn't state that it's normal, keep in mind what we learned from the interval. We're working with the t distribution. This is robust. We can still proceed, okay? We can proceed if we have, remember what I said, like a medium sample. So that is where 15 is less than N, which is less than 30. We want to graph the data. If the data has a slight skew, it is okay. But no outliers. And I don't have a ton of room here, I apologize. Okay, this is what I call that medium sample. Well, what if though N is less than or equal to 15? Then again, I want to graph the data. And I want a symmetric distribution. Again, no outliers as well, okay? No outliers as well. We have 20, sample size of 20. That is not greater than or equal to 30. So we're going to have to graph it. We did this in our calculator on the interval. Let's do it again now. If I go to my interval here, I'm going to go to stat. I'm going to hit enter on edit. I'm going to go ahead and I'm going to clear out L1. I'm going to split my screen so I can see both data here and my calculator. I'm going to go ahead now and type it in. So pause your video right now, type in 72 all the way to 70, and then hit play and we'll go from there. I'll pause it. Okay, ladies and gentlemen, what you should have done right now is you should have entered this 72 all the way down to 70. It's always a good idea to take an extra second and double check that you've entered it right. So we're going to do that now together. 72, 77, 68, 81, 85, 93, 97, 56, 75, 59. Keep going. 71, 78, 86, 94, 67, 66, 68, 75, 73, and 70. What am I doing right now, guys? I'm looking at this normal condition, and the normal condition is not met right now, but we know that the t-distribution is robust. So what I can do is looking at this, I say, okay, sorry, I have a medium sample. I'm going to look at that graph. I want to make sure that it is slightly skewed, if not symmetric, and I don't want any outliers. Again, we took these notes in the interval as well. I always suggest to look, when you're doing this, hit second y equals. Make sure that your plot 1 is the only one on. You don't want 2 plots on. So I'm going to go to plot 2, and I'm going to turn that off right now. Enter. And now I'm going to go back to plot 1, and I have that on. I like this box plot here because this is the modified box plot. It will tell you without having to do the outlier rule if there's outliers or not. I'm going to hit zoom 9. And I have a nice picture of my box plot here. There are no outliers. You do need to sketch this for me in the normal condition when this n is greater than or equal to 30 is not met. You need to sketch it, and then you need to say no strong skew, no outliers. And this looks pretty stinking, well, it's close to being symmetric, maybe a little bit skewed, right? But not much at all, okay? So no strong skew, no outliers. We are okay to proceed to the method. And our method here for us is a 1 sample, 1 sample, t interval for mu. Okay, now we're at the do parts. What do I ultimately want for the do? Well, let's talk about it here. I have an error in here, so I need to quick change it before I confuse anyone. Okay, for the do, what I want is I want to draw that picture, that sampling distribution. If you're ever asked, what is the sampling distribution? Remember, you're asked about the shape, okay? You're asked about the center, and the spread, the standard deviation. Okay, now I'm going to draw my picture here. My center, you guys, always comes from the null hypothesis. So if it's a proportion, it is that P. In this case, it is your mu. So mu is equal to, I think it was 77, but let's double check. Yep, it's 77. Now, notice my formula here. It's our standard deviation divided by the square root of n. We learned that when we learned the interval. Okay, so let's go up, and you'll notice, you guys, we have a list of data. There is no standard deviation that was given to us. We do know our n, though, so let's go ahead and fill that out. And then let's talk about what to do next. We're actually going to go right to the calculator. Okay, so let's do that now. When I go to my calculator, I could find what my standard deviation is for this data. So we don't have a population standard deviation. If we had a population standard deviation, we would be using a Z. So what we're doing now is we're using a T because we don't have a population standard deviation. That's the reason we're using this T distribution. We'll get into that a little bit more later as well. Okay, so let's just remind ourselves, what are we doing here? There's a whole mess of stuff going on. We're trying to figure out, just as a quick reminder, because sometimes I think you can get kind of lost in all the noise of what's going on. Let's refocus what is going on. We know that the average lifespan for Hawaii citizens is 77. We're wondering if it's less than that in Honolulu. We want to do a one sample t-test for mu. We can do that because we've met our conditions. Right now, we're setting up that sampling distribution. We know that the average is always our null hypothesis. And now we're talking about the standard deviation. We said, hey, we don't know the population standard deviation, but we can find the sample standard deviation. How can we do that now? We could run a one variable stats, or we can just go ahead and we can go to tests. These are all our inference tests. Remember, inference means drawing conclusions about a population. We're doing intervals or we're doing tests to do that. We're going to go right to the t-test right here, number 2. You should see this screen. So again, how did I get there on my own calculator stat? I arrow over to tests. I'm at t-test number 2. Okay, now I ask myself, do I have data or do I have statistics? What's been given to me? I have not been given an X bar or an SX. I have been given data. My data is in list 1 right now, so I'm okay to proceed on that end. This right here, mu naught, that is our null hypothesis. What is our null hypothesis? The mean for our null hypothesis is 77. Again, I told you my list 1 is where my data is in. Frequency will stay at 1. And then this right here is what is our alternative hypothesis. Our alternative hypothesis is a less than. I'm going to go down and I'm going to hit calculate. I'm going to bring this over my fanciness and we're going to talk about it at the board. Okay, so I have my SX. My SX is 11.11, so I'm going to fill this in right here. 1141. So I'm actually going to cross this up because I don't want people to confuse you. Remember, if we have our population standard deviation, we can use a Z. We don't have that. We have a sample standard deviation. That's describing our data. That is why we're using the T distribution. Now we have our X bar right here. This is what we observed. Our X bar is at 75.55. This is our statistics, similar to last time, except for we used a p hat. Our p hat was describing that sample. This X bar is also describing that sample. We're going to shade to the left. Why? Because our HA is a less than problem. Now before, what we did is we found a Z-score. We did ZOMS. A Z-score was equal to our observation minus our mean divided by our standard deviation. Now instead of ZOMS, for our T-score, we're going to use TOMS. What's the difference? Not much. When we find our T-score now, guys, that's equal to our observation, what we observed as statisticians. That's 75.55 minus our mean. That's the mean of the sampling distribution of that statistic. So that's 77 divided by our standard deviation of the sampling distribution for that statistic. And that is that sigma up here. Since I've already shown my work up here, I don't need to rewrite it in the denominator. I can just put sigma. If you're not someone who's drawing the picture, you do need to write this whole thing in where my standard deviation is, okay? My T-score then is equal to, right here, negative 0.5835. Right here, this is my p-value. My p-value is equal to 0.2832. And now I am ready. So I went to my table for a p-value, or I use my calculator. We're going to use our calculator. I will show you in class how to use that table. I can't see why you would have to know how to use that table unless your calculator would break, which is why I'll show you in class, but I'm not going to show you on this video. You can rewind and rewatch how I did that, but I'm going to do one more problem with you just to make sure we're clear on how to use that calculator and how to do a one sample t-test for mu. So Ultimately, what am I going to grade on this problem here? I want to see that you know how to get that t-score, my observation, my x bar minus my mean divided by my standard deviation. I want to see what that t-score is, and I want to see a p-value. And now I need to conclude. You guys, I need to conclude just like I've been doing for my other test, my one sample z test. Keep in mind, in a nutshell, how do I conclude, guys? I want to look at my p-value. If it's less than alpha, I'm going to reject the null hypothesis and have evidence for HA. If my p-value is greater than alpha, I fail to reject the null hypothesis and have no evidence for HA. Remember, guys, HA does have to be in context. One of these two things will happen. Let's look at our p-value now and conclude. Okay, our p-value. I noticed some of you guys are doing this. I like this. Is greater than alpha. You don't have to do that, but I like that. So we fail to reject our null hypothesis. We have no evidence for HA. Well, what is HA? HA is the mu is less than 77. What is the mu? The true mean lifespan of Honolulu residents. So I'm not going to say we have no evidence for, I'm going to say we have no evidence that the true mean lifespan for Honolulu residents is less than 77 years old. Okay, guys, the next example that I'm going to do, I'm going to modify it just a little bit. That's going to be part 2. At this point, if you want to start your homework, you can go ahead and try. The only thing I want to give you a heads up on the next problem that I'm going to do with you, instead of giving you data, I'm going to give you statistics. So we'll just be typing things into our calculator different, as well as the alternative hypothesis will be a not equal to. So that will be part 2. If you struggled with part 1, I would definitely listen to part 2. If you think you can pick it up without listening to part 2, that's fine with me as well. You can decide.